Okay, so solving systems of equation by graphing. So there's lots of ways to solve a system of equations. Today we're just going to be solving it by graphing. And so the first question is, what are the possible ways two lines can cross? So we can use like two pencils, for example. I'm going to use these two pens. You can use your two fingers. How might two lines cross? Somebody has one. Anybody else can do it with their fingers? How might two lines cross? Good. Okay, like this. Like this. Crossing. Yep. So that's one possible way. How else might two lines cross? So we're going to include the perpendiculars the same idea. How else might they cross? So we're going to use all of this as the same one. So how else? It's got to think out like different. So all of that is one. Thank you, though. You're right. I can see how you would think that is a separate one. Oh, I like that. Like they could be the same line. Yes, very good. So it could be the same line. There are two lines that are actually the same line. So what's the third way? A couple of you, when you were doing the shape with your fingers, you went from this to something else. How about this? What's this called? Parallel. That's right. They don't. So that means they don't cross. So three different possibilities. We have two lines. They can either cross at one point, they can be the same line, or they will not cross at all.
But it says like, what are the two ways?
So we're going to move on to solving by graphing. So solving by graphing. How do we graph y equals negative x minus 2?
Y equals negative 2. X equals
What kind of a shape is that?
A line.
A line. How do we know it's a line?
It's the line slope-intercept.
It's in slope-intercept form. So we start with the intercept of negative. What's the intercept on this one here? Negative 2. And then our slope. Negative 1, which is negative 1 over 1. So if I have to say something again, then I'm doubling the homework assignment. Okay, you guys need to sit quietly while I'm teaching. I don't spend the entire period talking. Thank you. Be polite. So we're going to go for our slope of negative 1. Where do we go from there? Down 1 and what does over 1 mean? Down 1, right 1. Now on this graph here, we're solving by graphing. So we want to get a third point at least. So we would go up 1 and left 1. Okay, I'm going to draw my line later. I recommend that you do it now. Mine is just a little problematic doing it on this board here. So now graphing this line, what's my y-intercept on that one? 3. So we start at 3. And our slope is? 2 over 3. So from there we go up 2 and right 3. So now I'm going to draw my two lines. I'm going to go, wait, 1, 2, down 2, and what direction 3? Left 3. That's good. I like that you're thinking about where they intersect. So here's one line, and then here's the other line. So, what is my answer to the solution? A hand, please, for what is the answer to this here? Yes, Jason? Okay. Sunny?
-3y.
Yeah, so this point here is -3, 1. That is your solution. Be sure to write that as your solution. Frequently, when doing these, a lot of students will just draw the graph and we'll stop there. But the actual solution is the point where they cross. Okay, so for number 3, what do we do on number 3?
Oh wait, now you have to get it like in the right form for the bottom.
Yeah.
For both of them.
So they're not in slope-intercept form. So we have to get them in slope-intercept form, don't we?
Yeah.
So how do we do that? Madison. That's right. Let's subtract the x first. So we get -4y equals -x plus 4.
Divide 4 on the sides.
Divide both sides by -4. I'm going to call on somebody. So we get y equals, Jimmy, what do we get when we divide by -4 there? So this -1 over -4 becomes, going to be a fraction. So we're looking at dividing both of these. So this is like a -1 in front of the x divided by -4.
Oh, so you won't.
Good. 1/4 x. I know that's a little tricky. And then 4 over -4? -1. So there's one of our equations. Let's go ahead and graph that. Start at -1. Up 1, right 4. And down 1, left 4. And again, I recommend that you draw your lines. Or it's a lot easier if I wait until I have both of them. So we want to get y by itself on this one here. So what would we do first? So let's see. Will, what do we do first to get y by itself on this equation? Uh-huh. Good. Good. So -y equals -x minus 2. Then divide by -1, and we get y equals what?
Positive x and then plus 2. And 1 over 1.
Yeah, and then the slope is 1, so we're going to start at a y-intercept of 2, slope of 1, which goes where from there?
1 and then to the left one. Like to the right.
Up 1 to the right 1, and then down 1 and left 1. So again, the reason I'm doing more points here is because we're solving by graphing, and when we go to hold our ruler, we can just hold it a little bit off. So we could make a slight error. So if we have more points, it's least possible that we're going to be more accurate. It's going to help us with our accuracy. So one of my lines looks like this. And then another line looks like this. So a hand, please, for what my solution would be on this. Good. -4, -2. And then the last one, we're going to stop at 4. So let's go ahead and do 4. So graphing that, we start on the first one, y-intercept of 4, slope of 3. So 3 is the same thing as 3 over 1. So because it doesn't fit, if I go up, I'm going to go down 3, and then what direction?
To the right one.
All right.
You left?
would be left because it's a positive 3, so to make that a positive, does that make sense? And so I'm going to do one more point, down 1, 2, 3, left 1. So there's one line, and then the other line starts at -3. And then I'm going to go up 1, 2, 3, 4 to the right 1. And my 2 lines. Up 4 to the left 1. Sorry about that. 1, 2, 3, 4, left 1. I changed my other class. And that 1, 2, 3, 4, left 1. And my line. Looks like this. And what's my solution there? Oh, yeah. -1, 1. Good. So what if my graphs did not cross? What would the solution be if your graphs don't cross? They're parallel, but what's the solution? No solution, that's right. So if they don't cross and they're parallel, which I love that you said that, then it's no solution. Does that make sense?